Hello, welcome to this video where we look at binomial distributions and calculate probabilities using z-scores. This really combines two previous sections. First, it's important to remember what a binomial distribution is. A binomial distribution was categorized as having two outcomes, success and failure. Okay? And then we had several variables here to help us measure that. N was the number of times we wanted to try our experiment. R was the number of successes. P was the probability of success. And Q was the probability of failure. It should be remembered that P plus Q equals 1 since your only options are success and failure. Then, in another section, we could calculate the mean, which was the number of trials times the probability of success. And we also had a formula for calculating the standard deviation of a binomial distribution. And then later on, in a normal distribution, we had the z-score formula, which would allow us to look up probabilities in a table. So, all the way down, we have binomial probability distributions, and the last line comes from a normal distribution. We're going to combine those two things. Here's an example of how it's going to work. It says Anne plays a card game against the computer and wins about 80% of the time. So she either wins or loses. That's why there's only two outcomes here. If she plays 30 times, what is the probability that she will win more than 20 games? So let's break everything down. What we're looking at is she's going to play 30 times, so that's our number of trials N. The probability of her winning is 80% or 0.8. Now it doesn't say it, but the probability of failure Q would be 20% or 0.2. Okay, 1 minus 0.8 is 0.2. Then some other things we need to find here is the mean or the expected value here. So we take the number of trials times the probability of success, and if she's playing 30 games with an 80% chance of winning, that means she's expected to win 24 times. And the standard deviation, square root of 30 times 0.8 times 0.2, in this case gives us 2.19. So these are all the variables that we need to work with. And from the problem it says, what's the probability that she will win more than 20 games? So you may remember that R was the number of successes, so we might say the probability of R greater than 20, or if we want to think about it in terms of the z-score data, we may use X to represent a raw score. So we're looking for the probability of winning more than 20 games. So this is all the notation coming from the problem. So let's continue on. There's a very special note when using z-scores for binomial distributions. And I'll go a little bit further in depth in the next slide. But when using the z-score formula with the binomial distribution, you always increase the interval by half a point. So in actuality, the way you would calculate these probabilities is a little bit different than the z-score, but it gives you fairly close to the same value. So to make sure that you capture that value, we always use a larger interval. So when we were looking for something greater than 20, when we want to make that interval bigger, which would be the right side of 20, we're going to have to go down. Okay, so it's not that we're adding half a point to 20, so we're adding half a point to the interval. So we want everything to the right of 20. So to make that bigger, we're going to have to go down below 20. So that's why we're using 19.5 here. Okay. So then we look at the z-score formula. We just calculated the mean and the standard deviation. Plug in that 19.5, we'll get a z-score of negative 2.05. At this point, everything works the same as how we work with z-scores, right, left, subtract from 1, intervals in between. The only adjustment really is that making the interval bigger. But when we look up the negative 2.05 in the z-score table, we get 0.0202, which means it's to the left of 19.5. So there's very little chance of being below 19.5 wins for n. But we really want to be greater than 19.5, so we want the right side. So we subtract that from 1, which gives us 0.9798. So as a percent, that means she would win about 98%. There is a 98% chance that she will win 20 of the 30 games. So it's very likely that she will win 20 or more games. So just to make sure you understand about increasing the intervals, here's one if we want a probability less than 20. Okay, so we want everything between 20 or below, so we need to make that bigger, so we add half a point. What we just did here, we want more than 20, so we have to go down a little bit lower to make the interval bigger. And the last example here, between 10 and 20, okay, we have to go below 10, which takes us to 9.5, and we'd have to go above 20, which would take us to 20.5. So we make it half a point bigger on each side. Okay. If you can make your intervals correctly and use the right mean and standard deviation from the binomial distribution, you will have no problem if you understood working with the z-scores.